All right. About the LAN, OSPF in LAN, we learned that there will be a DR-BDR election. Now we are going to focus on why there is a DR-BDR election, what is the advantage, and why these two addresses are needed, 224.0.0.6 and 5. Let's see that. Let's say we got 1, 2, 3, 4, and 5. We got 5 routers, and they all are connected through one LAN switch. We got a LAN switch. No, LAN I said. NBME is not LAN, it is WAN. This is LAN, a switch, a layer 2 switch. So when we have routers like this connected through one common broadcast domain or layer 2, we call this as broadcast domain or LAN, LAN environment, LAN relationship, LAN adjacency. When you have two routers, connected back to back, many times I have said this, I'm repeating again, connected back to back using Ethernet, even this is considered as LAN only because you got Ethernet. Whenever you're connecting to a switch, can you use a serial link? Not possible. Whenever you connect to a switch, switches are LAN device. They work on Ethernet standard. You can't use serial. So whenever you don't even have a switch, still it is considered as a LAN device, LAN network. Why? Because at any point of time, you may connect a switch here and connect more routers. So whether you have a switch in the middle or not, it is still considered as a local area network. Now, when it is considering as a local area network, there will be one router elected as a DR and there will be one router elected as BDR. Even in here, one will be elected as DR and the other one will be elected as BDR. What about the other routers? As I said, other routers, they're called as other routers only. Others. That's the name given. But we don't simply call it as others, we call it as DR others. In this scenario, you don't have DR other because you don't have third router. Here we got one DR and one BDR. You cannot have more than one DR and one BDR in a LAN segment. I want to repeat this statement. Do not assume that there will be only one DR in an area. I did not say that. I did not say that. I did not say there's only one DR in an area. No, I did not say that. In a LAN segment, there will be only one DR. So this side, if you have another Ethernet wire, this may be a DR. This may be BDR. This is another LAN segment. So for each LAN segment, there is going to be a DR and BDR. MD. See, this is one LAN. This is one LAN. This is another LAN. How can you say this has one complete LAN? Not possible. One LAN means one network. Definitely, network here and network here will not be safe. So the understanding of LAN as a beginner is like one building within a building, network within a. These are all funny stories. Those things are beginner stories. That's not LAN. Within a building, you may have many networks. Each network is one LAN. You understand? Okay, now whenever you got a serial wire connected, there is no chance of using a switch here. So definitely it is going to be a point to point, and there will not be any DR or BDR. No DR, no BDR. Whenever you got Ethernet, you will have DR, BDR. Now, why do we need this DR, BDR is what our next discussion. After which we will discuss how it is elected. Or you can do the other way. Let's first discuss how a DR and BDR is elected. How a DR and BDR is elected. Designated router and backup designated router. First of all, I want to make one thing clear that DR BDR is not the whole router. I told you, if this router connects to another router, sorry for the scribbling. Oh no, my pen is submitted. Okay. So what I'm trying to say is, you see here it may be 10.123.0.1, 10.123.0.2, whereas here it is 10.1.0.1, 10.1.0.2, 10.1.0.3, 10.0.1.4, 10.0.1.5. Now you see, this is different network, this is different network. Each network is a LAN. You understood now? Now, you see, this router is DR other, but on which interface? On this interface. In this interface, this can be a BDR and this can be a DR. So what do you understand from this is the DR BDR is with respect to the interface, not to the entire router. It's with respect to the interface, not to the entire router. A router may have different role. On one interface it may be a DR, another interface it may be a BDR, another interface it may be DR other. Each interface in a router is different LAN. In a router, if I have 4 interfaces, what do I mean by that? I have 4 LAN. In all the LANs, you cannot expect the same role. Anyway, coming to the story back, we are going to discuss on how it is elected. Now, DR BDR is elected during the extart state by comparing priority. You see, in the hello packets that they send initially using 224.0.0.5, not only sending initially, every time when the hello packet sent, in the hello packet, the priority on the port is also advertised. For example, this one has got priority 10. This one has got priority 5. And all other routers have got the default priority 1. Priority 1. Now, in the hello packet, the priorities are shared. Now, every router knows that the purple router has got high priority. So everyone will agree when purple router says I'm a DR. Actually speaking, the purple router first it will say I'm a BDR. And then again, after waiting some time, when there is no other router with high priority comes, purple router says, now I'm a DR. I'm trying to explain you the actual behavior. The purple router will not straight away say, I'm a DR. It will not say straight away. It won't say straight away, I'm a DR. The purple router will first say, because I have high priority, I'm a BDR. And then the purple router will do what? It will wait for some time. And because no one else has got higher priority other than this, it will promote itself as DR. Then this router will immediately say, hey, then if that is DR, then I am the BDR because I'm the next priority, high priority. And all other routers will call themselves as others. So based on the priority, the DR is elected. But the default priority is 1 on all the routers. The default priority is 1 on all the routers. In that case, in the hello packet, there is another entity called router ID shared. Every router will pick one router ID. You can also configure router ID. If you don't configure, it will pick the loopback interface address as the router ID. And if there is no loopback interface, then it will pick the physical interface address as the router ID. Now what happens is, The router with a bigger IP address as the router ID will become a DR. For example, in our scenario here, this router has got 10.1.0.5. Other router has got less than that, 1, 4, 3, 2. So even if the priority is not 10, first it will check the priority. If there is tie in the priority, you see everywhere there is a tie in the priority, all have the same priority. When the priority is same, then they compare the router ID. Because these routers don't have any other IP address, they will pick the physical interface address as the router ID. And the purple router's address is higher than any other router. Is this clear? Now, why is that is in point to point? We'll talk about that later. When you have serial wire, will there be a DR, BDR? I just said some time back. When you have a serial, when you have serial wire, will there be any master? Sorry, will there be any DR, BDR? Hello. This I said point to point serial link, which is also called as WAN link or point to point link. Will there be any DR, BDR? No. If you don't remember what I said earlier, now I am saying no DR, BDR. And the priority will be automatically be 0 in the WAN link, in the point to point link, in a serial link. See, if I draw like this, what it means serial link. Okay. If someone draws like this, it means serial link. It means point to point link. It means WAN link. You understood? So when there is a priority 0, there won't be any election. Even if you change the priority, it's of no use. Here only the router with the higher router ID will become master and the other one will become slave. We'll not discuss on this thing now. Our focus is on why DRBDR, how DRBDR. We are trying to understand this page. All right. Now we understood that based on the priority, the DR, BDR will be elected. If there is priority a tie, if no one changed the priority, if the priority is same, then it compares the router ID. You got it? It compares the router ID, and the one with the bigger router ID becomes the DR. The second biggest router ID will become a BDR. You got it? Okay. Now, why is there DR, BDR in a LAN environment? To avoid loop, to avoid duplication, right? To avoid duplicate of update. You see, for example, if there is no DR, BDR, what will happen? That is what? Very good. You already know the answer. So, if there is any change, then green will send the information to brown, purple, and then the light brown, and then the blue. And blue will think that my other neighbors don't know it, so blue will also send it to brown, purple. So this becomes a duplicate. To avoid this, one of the router is DR, so only to DR, whenever change happens, they will do the exchange of info. In short, what I want to say is the exchange is not available between other routers. So these two routers will be only in two-way state, and so this one. But with this router, everyone will have, with these two routers, they're called as DR family. With these two routers, all will have full relationship. The blue lines are called as full relationship, full adjacency, meaning whenever the change happens, they will exchange the change. They will send it. So DR will receive from green and it will send to everyone. When DR receives the change from green, BDR will also be receiving it, but BDR will not forward it to anyone. It's only a DR router that can forward the updates. So do you remember to which address the DR will use to forward the updates? Correct. When green got some update, do you remember to which address it will send the update? My dear friend, listen to the question. When green wants to send an update to DR, what address it will use? Exactly. If it sends to 6, it will go to both DR and BDR. It will go to both DR and BDR. And DR will use .5 to send to others. Whenever there is a change, for example, green found some change, it sends the update. But earlier also green has sent an update. What is the difference between that and this? The change is the difference. So whenever there is a change, to notify the change, it will increment the sequence number. For example, if you see here this output, what does this output shows? This particular router has advertised some change to this router C, and it was the 8th update. See, sequence number is 8, and this 8th update came 48 seconds ago. Here from this particular router, 6th update came from 212 seconds ago. See, it will actually start from this number. It will start from this number. You see, 0x8, 0008. It will start from 8. And when all this becomes F, it is not possible to become all F, because in every 1 hour, it will reset. So within 1 hour, it cannot reach FFFF. In case if it reaches, it will reset back to this number. Okay, it will reset back to this number. And you will see, like, if it increases, this 8 should become 9. Why it is becoming 7? Only then it can reset to this one, because the next number is 8. It needs to start from 8 only. If it ends with 8, then it will start with 9. 9 is not allowed. So when all this becomes F, it will go to 7FFF. You understand? So that it can restart. Did you understand? Not that important, but good to know. See, every 30 minutes, they will send the database to make sure that everyone is having same identical synchronized database. But oh, sorry, is it okay now? Is it okay now? Okay. Every 30 minutes, every OSPF router will send the database to make sure that all are synchronized. But not only that, every 1 hour, it will reset the sequence number to this. You understand? So that it will never reach the maximum. All right. It will again come back to this one. It will come back to this one. It will come automatically. That is how it is designed. It's not, it won't decide, reset. It will always do it. All right. So I have explained you this, and now this one is a debug. I explained you this. What packet it is? Type 1. What packet it is? Hello packet. Type 1. What is type 1? Hello packet. The command you use is debug IP OSPF packet. All right. So this chapter was giving us more information about the packet types. That's the title of the chapter. And then the adjacency states, and then DRBDR, and then the sequence number, and then the reset timer, and then resynchronization timer. Resynchronization is every 30 minutes. Resetting of sequence number is every 1 hour. All right. I think we'll start